Okay, so now we're going to go through page 2 of the group work. So the first one is a word problem where we have to find the cost function and the profit function, and a piecewise function, then even, odd, or neither, and then common function and transformations, average rate of change, and looks like a difference quotient. Okay, so starting off with the word problem. Company produces a product for which the variable cost is $5.35 per unit and the fixed cost is $16,000. So that's all cost that somebody has to spend. So for the cost function, it's like $5.35 for every part for the product that they sell. So if the product is X, then it's X times $5.35, and that's how much they spend making it. And then maybe the $16,000 might be like some sort of fixed cost that they have for like rent or something like that, and we add that onto the equation, and that's the total equation, the cost equation, because it's all the money that we're spending. And then profit is a simple equation that you construct by taking the revenue function, which we're going to get in a second, and subtracting away the cost function, which we just found. So revenue means the amount of money that we get back from selling things, and it looks like we're selling this product for $8.20 each, so 820 times X, that's revenue. And then we're subtracting away the cost function, which we just put together, 535X plus 16,000. Okay, and then you can just leave it like that. That's the function, and it's all done. Sketch the graph of the piecewise function defined by hand. Okay, so this is a linear equation, and it starts at X equals 0, so we just build a little t-chart there starting at 0, and it's for x values less than 0, so we go to -1, -2, -3, and so on, and then plug those in. So if I plug in 0, I get 5. If I plug in -1, I get 2. If I plug in -2, I get what would that be, -1. And if I plug in -3, I get -4. All right, then for this equation, x minus 4, my x values again start at 0, and then they go up greater than 0, so 1, 2, and 3 maybe. So if I plug in 1 minus 4 is -3. Oops, -3. If I plug in 0, that's one I should have gone with first. I get -4, so -4, and then -3. If I plug in 2 minus 4 is -2. 3 minus 4 is -1. So I'm going to start graphing these out. Since I have an equal sign on this 0, then that means that this is going to be the one that has a closed circle. And that means that this one's going to be the open circle since it does not have an equal sign on it. So I start at 0, 5, so over 0, up 5. And let's actually just graph it all out at once. Let's see. So my biggest number here is 5, so go up by 5 each direction. 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here we go. So 0, 5 is going to have an open circle. -1, 2 is the next point that I graph, so -1, 2. -2, -1, so -2 down 1. -3, -4, so left 3 down 4. And here's our first part of our piecewise function. It just goes through those points up to the, let me get closer to where I need it to be, and then up to the open circle part of it. All right, the other graph is going to have a closed circle at 0, -4, so over 0 down 4, closed circle, and then 1, -3, so over 1 down 3. 2, -2, so over 2 down 2, and then 3, -1, so over 3 down 1. All right, so there's the rest of our graph, and that's the piecewise function. Pretty easy. Determine whether the function is even, odd, or neither. So when you have to do that, you just plug in -x for your x value into the function, and if it's even, that means that all of the terms stay the same. If it's odd, all the terms are different. And if it's neither, then neither of those cases are true. So let's take a look at what happens. When we plug in -x for x, we get -x squared minus 8, and then that whole thing squared. Well, -x squared is the same as saying -x times -x, and we all know that a negative times a negative is a positive. So this just turns right back into a positive x squared. And then we have that -8 there, and then squared. Well, if you look at the function, even though we plugged in -x, it ends up being the exact same thing. If it's the exact same thing, then none of the terms have changed. They're all the same, and that means that this is an even function. So easy enough, even function there. Then this one says identify the common function, describe the transformations to the graph. Well, this V shape is indicative of an absolute value function, so that's the common function. And when we graph it out, I'm going to use the coordinates that we have over here and the axes that's already on the graph. It looks like this, and the whole graph has just been moved up by 1, 2, 3 units. So the only transformation that has happened is that the whole graph has shifted up by 3 units. And now if we want to write out an equation for that, it's pretty easy. Y is equal to the absolute value of x, and we're moving up at 3 units, so we add 3 outside of the absolute value. So that's all we have to do for that. For average rate of change, that's the slope. So for slope, we need 2 coordinates, and that's where these values come in handy. Those are your 2 x values for coordinates, -2 and +4. We need to find the corresponding y values, and to do that, we plug in to this function. So we plug in -2 squared plus 2 times -2 minus 5. -2 squared is 4. 2 times -2 is -4. And then minus 5. So 4 minus 4 minus 5. So 4 minus 4 is 0. 0 minus 5 is -5. So -5 is our corresponding y value. If we plug in 4, we get 4 squared plus 2 times 4 minus 5. So 4 squared is 16. 2 times 4 is 8. 16 plus 8 is 24. And 24 minus 5 gives us our answer for the y value, which is 19. Now we just do slope for this. So x1, y1, x2, y2, and then plug it into the formula. y2 minus y1 over x2 minus x1. So this is 19 plus 5, which is 24, and then 4 plus 2, which is 6, and 24 divided by 6 gives us our answer for the average rate of change, 4. All right, now we go on to the difference quotient. Now, when we're talking about the difference quotient, I want you to know that this is the most difficult part that we would ask for you to do, a quadratic. More likely, we'll probably ask you like a linear equation. So if you can handle linear equations, then this shouldn't be that bad. But even a quadratic's not terribly difficult. Let's find out what each of these parts represent. So this is going to be a composition. We're plugging x plus h into the x value here. That's this. F of x is just the regular old 2x squared plus 1 function, and h is h. So far, this is how our difference quotient looks so far. We have something that we're going to find, this composition, and then we have minus our original function, which is 2x squared plus 1, and then we have h in the denominator. Let's find out what that composition looks like. So we're going to take the f function, f of blank, is equal to 2 times blank squared plus 1. That's our input values, and we're going to plug in the value x plus h. So x plus h goes here, x plus h goes here. Now let's evaluate this and see what it is. Remember your order of operations when working through something like this. You've got to square it first and then multiply by 2. Do not distribute the 2 in. Whatever you do not do that. So we're going to work on the x plus h squared part of it first. X plus h squared is the same as saying x plus h times x plus h. Then we just do distributive property or foiling, whatever you want to call it. X times x is x squared. X times h is xh. H times x is xh again. And then h times h is h squared. So when we combine all the like terms here, we get x squared plus 2 of these xh's, and then plus h squared. Okay, so that's this part right here. Now we do the rest of it. So this is 2 times that, so 2 times x squared plus 2xh plus h squared, and then plus 1. All right, so I'm going to distribute the 2 in there, and I'm going to add all those parts up here just to make it easier on myself. So 2 times x squared is 2x squared. 2 times 2xh is 4xh. 2 times h squared is 2h squared. I'm going to erase that little minus sign there, and then I have this plus 1 still on there, so plus 1, and then minus all this stuff. Now, this negative has to distribute into all of the original f functions, so I'm going to distribute the negative in there, and I get 2xh plus 2x squared plus 4xh plus 2h squared plus 1, and then distributing the negative, I get negative 2x squared and a negative 1. If we've done this correctly, All the terms that don't have h's on them should cancel out. So 2x squared and negative 2x squared cancels out. 1 and negative 1 cancels out. So we're left with 4xh plus 2h squared over h. Then we just simply divide out the h's, and we've got our difference quotient. Boy, sorry about that. I wasn't keeping track of where I was writing it. It looked like it got a little off screen there. Anyway, so if I divide out the h's on both of these terms, if I divide out the h here, I get 4x. And if I divide out one of the h's here, remember that 2h squared is the same as saying 2h times h. So if I divide out an h there, I'm just left with a 2h, and that's it. So 4x plus 2h would be our answer. So that is the end of the second page. So yeah, if you have any questions, make sure to contact your teacher, or talk to some friends, whatever. They're all doing the same kind of stuff too. All right, that's it.